intervals, zeros, and increasing and decreasing functions. It's a microphone, and it's an old school one Mr. Tatum gave me. Well, Josh isn't here, so he's gonna need the lesson. I didn't think about it yesterday when y'all had to leave for your pictures. Yeah, and Lamia, that's who else is going. I was like, it's not just Josh, somebody else is going, but I couldn't think of who it was. All right, so for this one, if you look here, does it include -3 or not? It does. So when we notate it using interval notation, it's going to be a bracket, a brace. And it's going to go from -3 to what number? 2. Is 2 included? So it is also going to be a bracket or a brace. For this one, what's different? It does not include -3. So instead of a bracket, to show that it doesn't include it, we do it as a parentheses. So we'd have parentheses, -3, and then what? 2, and then a bracket. Does that make sense? Looking at this bottom one, let's start with our right endpoint. What would it be? What? 2 and a bracket. Y'all see that? What is our number over here? Negative infinity? Is negative infinity an actual number? It keeps going, right? Forever and ever. So you have to use a parentheses. Anytime you use infinity or negative infinity, they're going to be parentheses because it never actually ends. You can't include infinity. It just keeps going and going and going. Y'all see how that works? So whenever it says write it in interval notation, this is what it's talking about, using the parentheses or the brackets. All right, so we want to designate the following by using interval notation. It was closed. Yeah. Anyone want to come try figure out what the interval notation would be? Someone go ahead. I don't care. Do you agree? Any questions on that? Okay. Someone want to go try B? Is that correct? What's wrong with it? You just left off your negative. But yeah, but the parentheses and the brackets were correct, right? I'm more concerned about that right now than that he got the -5 instead of 5. Does that make sense? Okay. I'm gonna try C. Then why didn't you go, Zach? Do you agree? Do y'all see how that works? No? Is 6 included in this one? So that's why it's a parentheses, not a bracket. The infinity? Okay. If you draw it on a number line, 6 is here. Which way is it going to go? It's going to go. I do my infinities like that because whenever I learned it, I was writing my 8s like that. Oh no. I just did 2 circles next to each other. Most people do it like that. Or, well, or like that even. I don't really care which way it is. Any questions on these? Y'all see how this works? Okay. Oh, that's it. On which of these is the function positive? So first off, let's figure out where the function is positive. Is it positive when it's over here? I mean, is it negative when it's over here and positive when it's over there only? Like all this is negative and all that is positive? Okay. No, you wouldn't use absolute values. What, Matthew? It's a quartic, but you don't, I mean, that doesn't. We don't care what the function is. We're just trying to look at the graph and figure out where it would be positive. So you don't think it's negative all over here and positive over here? Okay. Is it positive above this axis? And then negative where? Negative in this area? Does that make sense? It's positive when it's above your x-axis, and if it's below the x-axis, it's negative. Y'all see that? So it would be from here to here. What? No, no, no. Positive. What about from here to here? It's negative here. In this area? Here? And then here. All right. So it asks us, which of the intervals is it positive? Well, how many intervals do we have? We have 3 that are positive. Do y'all see how that works? Okay, so now that you know which intervals we're looking at, how would I notate this first one? Parentheses or bracket? Okay, we're going from -8, and that would be a bracket. Okay, what's the left side of it? Yeah, it keeps going. It was an error. Yeah, there was an arrow. I kind of covered it up when I drew on it. So it goes to infinity, negative infinity, and is it a parentheses or a bracket? Anytime you deal with infinities, it's parentheses. Do y'all see how that works? Okay. For this next one, what are going to be the endpoints, the numbers? -4 and 4. Now we got to figure out if they're parentheses or brackets. How many think they're brackets? How many think they are parentheses? I do. They are parentheses. Here's why. At this point, it is actually 0 because it's on the x-axis. Does that make sense? Oh, that is a... Yep, that one's still... X-axis is a 0. And that's where it actually is -4. So whenever we get just above -4 is when it becomes positive. It's like on your number lines, you have an open circle, it keeps going, you have another open circle. Does that make sense? Because it did not include -4 and 4. And then what would be the last one? Does that make sense? Unless it includes the 4, -4, 8, -8, infinity, negative infinity, parentheses. All right. We're going to graph this, and then we're going to check it on our graphing calculator. What are going to be the zeros of this function? Do you agree? Okay. On the graph, if they are a 0, what does that mean? It's where it crosses the x-axis. So we're going to put a dot at 0, at -3, -6, 2, and 5. Does that make sense? All right. In between each of those points, it's going to change from positive to negative. On the last graph, at each of the zeros, it changed from positive to negative, back to positive, back to negative, back to positive. Does that make sense? Okay. So on this one, we just need to figure out where one interval, whether it's positive or negative. Doesn't really matter what interval you pick, but what number do you want to use? 1. So we're going to look at this interval. So if we plug in 1, we have 1 times what? Times, times, times. Do I really care what the number is? What am I only looking for? Positive or negative, right? Positive, positive, positive times negative is the positive number. So this interval is what? It is positive. The interval to the right is negative. This interval is positive. This interval, and this interval. Y'all see how that works? Any questions there? Okay. For now, we'll get to graphing it. All right, let's graph it on our graphing calculator and see if we got the intervals correct. Where are you going to go in your graphing calculator? You can go to y equals And then what are you going to do? You're going to plug it in, and then you're going to graph it. How many of y'all got 4 lines when you graphed it? I did. What's your window right now? Like -10, 10, 10, and -10, right? So we need to change it probably. Our x-axis, we only went from -6 to 5. So do we need to change our x values? Those were good. What do we need to change though? The y values. So yeah, for the y, -700 and 700. Should our y scale still be 1? Should we have a tick mark every 1? No, because it'd just be a solid black line. It doesn't have enough pixels to show. I'm going to say every 100 so that there's 7. Haven't quite figured out how to show to record the graphing calculator on the document camera so that they'll see it. That's kind of what mine looks like. Mallory. I'll have to look up what that says. I don't know what invalid dimension. I don't know. I don't know what that means. Anyway, other than Mallory, any questions on the graphing calculator? I'll have to figure out what's wrong with that one. Okay. All right. A tangent. Do you remember tangent from geometry? Tangent to a circle. What is it? It touches a circle just at one point. No, oh, sorry. No, like dealing with the circle. If it touches, it's just going to touch it at one point. Okay. So that's the tangent we're looking at now. Tangent to the curve is a straight line that touches the curve at only one point. The same concept is if it's a tangent to a circle, but instead of a circle. The slope of the curve at that point is the same as the slope of the line tangent to the curve at that point. At this point, the slope of the curve that's red has the same slope as the black tangent line. Does that make sense? And that tangent line that is not really drawn like a tangent line due to the way I drew it, but it has a different slope because the point here has a different slope than right here. Does that make sense? A graph is increasing if for every increasing x, you get a larger y value. Look at my little picture. I'm starting over here. What's happening to my x values as I move this way? They're getting larger, right? They're going from negative numbers, getting closer to being 0, right? What are happening to my y values? They're increasing. So right here, what is happening? Is it an increasing or a decreasing? It's an increasing function. Does that make sense? Okay. The graph is decreasing if for every increasing x value, you get a smaller y value. This blue part of my graph, what is it? Decreasing. As my x values, they're still getting bigger, right? They're going further this way. But what's happening to my y values? They're going down. So that's a decreasing part of a function. Does that make sense? It'll ask you positive, negative intervals and increasing, decreasing intervals. And you want to use look at this graph. It says find a point with a slope of 0. Well, 1, 2, or 3. Which one has a point, a slope of 0? What does a slope of 0 look like? A flat line, horizontal line. Is that a horizontal line? Pretty close. Do y'all see how that works? Any questions on that? Okay. Which one has a positive slope? Is that slope increasing? Does that make sense? Which one has a negative slope? Is that one decreasing? Y'all see how that works? Any questions on that part? Okay. Now it says, over which intervals does the function appear to be decreasing? What would be one interval where it is decreasing? Where? interval notation. Someone says D to E. Someone says B to C. Either F to G, or you could say F to infinity. I think either of those. Y'all see how that works? We're basically looking for where are the slopes going down. Any questions on this? Interval notation too difficult? The more you practice it, the easier it'll get. Soon it'll